Thank you all very much for being here. My name is Erika Mildred. I live in Plano, Texas, receiving God's gifts with my husband Colin and two daughters, Emma and Jordan, at Faith Lutheran Church in Plano. And I am excited to be with you here today. A little bit more of a background and introduction to me. First, the 2021-2022 school year marks my 15th year of teaching in Lutheran schools. Since 1999, I have taught at a Lutheran high school in Sacramento, California, followed by classical Lutheran schools in Colorado, Iowa, and now Texas. And I currently teach for Faith Lutheran School in Plano, Texas, and I also teach for Wittenberg Academy, which is our online classical Lutheran school. This presentation today is based upon a mixed methods research project that I conducted as a capstone thesis project for my master's in education, curriculum and instruction mathematics, which I completed this spring. And this research, and really my whole program, was an exceptional experience. Now, I say that knowing that I studied at the University of Texas at Arlington. It was a secular, large university. It was a program, because it was housed within the education department, that was staunchly constructivist from beginning to end. Although I got a little bit of a reprieve when I did my mathematics courses, as opposed to the ones that were labeled with an EDUC in front of the number. But this allowed me to share the benefits of and blessings of a classical model to many teachers across the country who were taking the course and the program just as I was. I would say pretty much, I think all of the people in my program were already classroom teachers. They were already educators, ranging from my actual degree, even though we got to focus as we went into it, but my actual degree is K-12. So they often gave us kind of a choice of kind of 3 projects or 3 papers to write and so forth as we went through. And I always kind of steered toward the high school level, which is what I do at Faith. But it allowed me really to share the blessings of classical. It's weird for us because once you've heard of classical education, it just seems like, well, of course, people know about it. You know, maybe they choose to do it a different way, or their hands are tied because of the school in which they teach. But many still haven't heard of classical education. And so that was a privilege to share with fellow teachers as well as to my professors. And the results of the study, which I will share in this presentation, also served as an excellent testimony to classical ed. So the 4 classical tools that I focused upon in this research included memorization, repetition, recitation, and Socratic method. Before we dive into these tools, it is important to first understand the history of the 7 liberal arts, the shift in the integration of the arts of language and the arts of number, and how these classical tools for learning became housed primarily in the Trivium. Today, the language arts and the mathematical arts are typically separated in the structure of departments of education today, thereby requiring the purposeful integration of the 2 by teachers. But historically, this was not the case. The structure, design, and valuing of mathematics education in antiquity, therefore, cannot be overlooked. While the coining of the quadrivium is often credited to 6th century mathematician and philosopher Boethius, these 4 mathematical arts were actually first named by 4th century BC mathematician Archytas, who was a friend of Plato and the last of the Pythagoreans. He is the one who first divided it into 4 categories: arithmetic, numbers at rest; geometry, magnitude at rest; music, numbers in motion; and astronomy, numbers in magnitude and motion. Dr. Korchak reports that the language arts of the Trivium and the mathematical arts of the quadrivium comprise what we call the septem artes liberales, or the 7 liberal arts. And they have been the foundation of Western education for the past 2,000 years. Both Cicero and Quintilian referred to the 3 literary arts of grammar, logic, and rhetoric. And Cassiodorus, who was a contemporary of Boethius, referred to all 7 liberal arts, including those of language and those of mathematics. Finally, by the 9th century, both the trivium and the quadrivium were firmly established as the 7 liberal arts by which one received a full and liberal education. Thus, it is interesting to note both the prominence that the quadrivium had in the Septem Artis Liberales, as well as the connection both the trivium and the quadrivium had to one another. The language arts of the trivium and the mathematical arts of the quadrivium were not historically subjects to be mastered and were never designed to stand alone as the entire curriculum, but instead were more of a content methodology to acquire wisdom, truth, and intellectual virtue. As such, all 7 liberal arts stood as equals to one another, and all 7 were integrated into particular areas of educational study. A significant change, however, occurred that greatly affected the mathematical arts of the quadrivium with the rise of humanism in the Renaissance. According to Grant, humanists began to place a much higher value upon the language-based arts of the trivium and saw the mathematical arts of the quadrivium as of secondary importance to the study of the humanities. While some Renaissance scholars still incorporated all 7 liberal arts into their pursuits of art, philosophy, logic, and music, and of course that's interesting music, because that's one of our quadrivium, the Renaissance adopted widely a curriculum, which they called the Studia Humanitatis, from which the mathematics was explicitly excluded. The Age of Enlightenment further separated the trivium and the quadrivium, the word-based subjects and the number-based subjects as considered as significantly different. And I think it's interesting to note, a lot of times when people ask me what I teach or what my background is in education, I have a Bachelor of Arts in English and Communications, and I have a Master of Arts in Mathematics. And they look at me like I'm very strange. And to be honest, even the people within my program, many of them had a degree different from mathematics, but does anyone know what their bachelor's was in? What? Science. Yes. Science and math go hand in hand. English and math? What? So we can see that that separation that started during the time of the Renaissance really is in full effect today. In addition, the rise of the Industrial Revolution, the advent of new educational theories that we heard somewhat today discussed from Dr. Korczak, such as cognitivism, behavioralism, and constructivism, along with a mass producing and an institutionalization of education, caused a moving away by many schools from the liberal arts approach in favor of a more utilitarian and pragmatic approach. In addition, the literature reveals that even when a liberal arts approach is taken, the pedagogy, methodology, and exempli place far greater emphasis upon the first 3 of the 7 liberal arts than upon the last 4. From history, we can see that the language arts of the trivium and the mathematical arts of the quadrivium were designed and first implemented to work in harmony with one another as equally important arts. The history also reveals why, especially for schools like ours that employ the classical model, language-based strategies that we find in the trivium must be reintegrated into mathematical classrooms today. So circling back, the 4 classical tools upon which this research was focused included memorization, repetition, recitation, and Socratic method. I have chosen to name these 4 tools trivium tools, both because they historically came to reside primarily in the language arts of the trivium, and also because of the present need for classical educators to pull these tools back into use and predominance in the quadrivium. So at this point, some of you may be thinking, but we use these tools in the math classroom. After all, we memorize multiplication tables, we memorize measurement conversions, we memorize formulas and how to use them, and this indeed is true. However, when you think back to your end of the year recitations in the classroom for parents this year, the chanting you do every day with your students, the weekly memory work that you assign to your students, the delivery of a Socratic method in questioning, or even the annual CCLE recitation contests, how many of those activities are housed in the liberal arts of the Trivium versus the Quadrivium? If we are honest, we will admit that we utilize these classical pedagogical tools far more often in the 3 arts of the Trivium than in the 4 arts of the Quadrivium. So the purpose of this mixed methods quan-qual study was to examine the effects of the 4 Trivium tools on middle school students' algebraic equation understanding. Specifically, this study looked at the quantitative improvement gained from utilizing language-based Trivium tools within a Quadrivium classroom, studied students' feelings and perceptions about algebra, both before and after treatment, and assessed long-term retention, frequency of utilization, and possible internalization of Trivium tools for algebraic equation understanding. Because a longitudinal study was not a practical design for my master's thesis, as I wanted to graduate, the study was designed using 2 different student groups. Group 1 consisted of 7th grade students who participated in both the quantitative and qualitative portions of the study and helped to examine qualitative improvement in student feelings and perceptions. And then group 2 consisted of 8th grade students who had taken my math course, a 7th grade math course, as 6th graders, and their participation helped to assess the long-term retention, frequency, and utilization and potential internalization of Trivium tools as well. The literature review revealed that students' struggles stem from the symbolic nature of algebra and from the inability to connect arithmetic that they have been prior studying in their studies to algebra's symbolic notation. Past studies that I found often equated the study of algebra for students to that of a foreign language. And if we think for a minute and pause, we know Latin is very important in our schools. And we were discussing with a few before how early we start that Latin exposure. And yet we don't do that for the symbolic nature of algebra. Not to say that we want our 2nd graders figuring out algebraic formulas, but neither do we want to stick our 2nd graders in a readings course for Latin. So we have found a way to do that at the grammar level for those younger students, preparing them. But yes, thinking of math, and especially algebraic equations, as a foreign language is helpful for us to understand that gap that sometimes exists for students. The research seemed to indicate that students need to learn to, quote, speak the language of algebra in order to build confidence and understanding. And the research found that language-based strategies can assist students in developing algebraic equation understanding. The Trivium tools of memorization, recitation, repetition, and Socratic method can then assist classical educators as we teach students to translate the symbolic language of algebra and of algebraic equations. So here are my 3 research questions. So the first one is, what are the effects of utilizing the Trivium tools on middle school students' understanding of solving algebraic equations? I measured that one quantitatively. The second one is, how does the regular use of Trivium tools affect middle school students' personal confidence and attitude towards solving algebraic equations? This was measured qualitatively. And then the third one, which these 2 were for group 1, my 7th grade students. The third one was, to what extent do Trivium tools promote enduring long-term understanding of the nature and format of algebraic equations? I measured that also qualitatively with my 8th graders who had taken my class 2 years prior. So even though 2 of the 3 research questions were qualitative in nature, the study still was predominantly quantitative in design. The quantitative portion took a total of 10 days of classroom, a pretest, 6 days, actually an interview, 6 days of treatment, the post-test, and then another interview. I chose the pre-test, post-test single group design for group 1 for the quantitative research, and I used a qualitative case study approach for both groups to complete the study. The study was conducted during this past school year. I was very blessed that our COVID restrictions were minimal and that the 7th grade families happened to be a group of families that wanted their kids in person, because that was something over the summer that I greatly worried about, that might throw a wrench into my study. But in fact, all of the 7th grade students were in person for this study. There were 12 7th grade students in group 1, and there were 3 8th grade students in group 2. So as I said, before treatment, I gave them a pre-test. It consisted of 10 one-step, 2-step, and 3-step algebraic equations. And for those of you who may not teach algebra to your students, 1-step means there basically is one thing you have to do to remove something away from the variable to solve for it. 2 steps means you have to do 2 things, and 3 means you have to do 3 things. I found this probably the most interesting. All equations were taken from the 6th grade mathematics book. So we do Saxon through 8th grade at our school, and we do, if any of you came to, it's Mr. Girth, right? Mr. Girth's session yesterday, we use course 1, course 2, course 3. So all of them were taken from the course 1 book, and they were now all course 2 students, with only coefficients and constants changed. I didn't make them look exactly identical, but that was the only way in which I changed them. Instruction during treatment consisted of the use of the following Trivium tools. We memorized terminology through the creation of study cards. I do study flashcards in all of my math classes. The students have told me that it's very strange because they have never been asked to do flashcards for mathematics. But again, if you think of the research and the fact that math to some, and maybe eventually to all, is likened to a foreign language, where also do we do a lot of flashcards and study cards? In Latin, right, to learn the vocabulary. So we did that together. Terminology included constant, variable, equation, terms, like terms, what we can do with like terms, operations, and inverse operations. I also used instruction using Socratic method, verbal analogies, and classroom discussion to build understanding. Yes, we had discussion in math class. I also used recitation and repetition of terminology. A Socratic method procedure for systematically solving equations, something I call 3 questions, and for those of you who came to my lesson planning, you'll get to see a review of that at the end of today, along with verbal analogies to help students with concept understanding through visual and verbal clues, using common objects and images. One of my favorite ones I like to use with the students when we talk about what a term is and what terms are, is we use the simile, terms are like train cars. So they are always connected by either an addition sign or a subtraction sign between them, so that they can easily find how many terms there are in an expression on one side of the equal sign or the other side of the equal sign, or perhaps all together in the equation totally. We also talk about things like we chant something called the sign in front of the term stays with the term, and we have all of these kind of jingles and chants and little clues that we use in English to help them understand the symbolic nature of the math. Participants in group 1 were then given a pre-test, prior to all of this, they were given a pre-test, interviewed the following class period to gauge self-efficacy, and then they were given treatment over 6 30-minute class periods. They were then assessed with a post-test and interviewed the following day, following the post-test, to again gauge changes in the students' feelings and attitudes. Participants in group 2 were only interviewed The questions posed to both groups were recorded in Table 5 in my study and can be found in the handout that was provided to you. I'll give you just a moment to kind of take a look at the types of questions the students were asked. One of the things I wanted to know in this study, I knew that what I've been doing, because I've been doing it for many years in my classroom, I know it works. I know that students then understand that didn't before. But what I wanted to do is I wanted to create a study in a way that I could measure it. Not because I personally need the verification of the statistics, but our society does. We live in a society that is very driven by data and sometimes even skewed data at that. And so I wanted, in addition to just saying, trust me, this works, it's amazing, we love classical education, I wanted to do a study where we could then point to the numbers, especially since we're talking about a study in the quadrivium. So a quantitative comparison of test data was used to see whether there were differences in students' understanding of solving equations algebraically after using and teaching them using Trivium tools of memorization, repetition, recitation, and Socratic method. The data collected on variables, the pretest and the post-test, were first screened for possible outliers using the interquartile range rule. The study then used descriptive and parametric statistics to describe the data using arithmetic means with standard deviations and paired t-test scores for data analysis to compare the pretest and the post-test for the quantitative component of the study. For the qualitative interviews of Group 1 and Group 2, categorization and interpretation of the data occurred. Recurrent themes among the narratives emerged, and iterative interpretation was then conducted from the data in both groups. For answering research question 1, a paired one-tailed dependent samples t-test was conducted using data collected from the pretest and the post-test. For answering research questions 2 and 3, data gained from the group interviews were read multiple times to look for emerging themes. They were then coded and re-examined again. A narrative was developed guided by the themes that emerged. So, the quantitative results. The data, pretest and post-test scores, were entered into an Excel spreadsheet with rows denoting participants and columns denoting variables. The data were screened, as I mentioned before, using the interquartile range rule, and no outliers were found in either group of data. Both the pretest and post-test were carefully constructed to create equivalency between them. A nominal scale was applied to each participant randomly so that no test score could be attributed to any individual participant. As I said before, a paired one-tailed dependent samples t-test was then conducted to compare the data from the pretest to the post-test. And I used an alpha level of 0.05 for all statistical tests. The post scores after treatment, with the mean of 89.75 and a standard deviation of 9.96, were dramatically higher compared to the pretest scores prior to treatment. Mean of 46.25, standard deviation of 15.86. The Pearson product moment correlation coefficient, and you can see that formula toward the middle of the slide right here, revealed that there was positive medium correlation between the pretest and post-test scores, and that this dependent samples t-test indicated that there was a significant statistical difference between the test scores. Now, whenever you write for a professional, either journal or for your master's degree, if it is less than 0.001, that's what you're supposed to say. But it was actually 0.000000315. And the lower the number in statistics, the higher the likelihood that nothing else other than the treatment caused this change. The results of the t-test provided an answer, really a very strong answer, to the first research question, and suggested that Trivium tools were indeed useful in promoting algebraic equation understanding for the middle school students in Group 1. Before I get into some interesting trends that emerged, I think it's important for all of us to keep in mind that this was the very first activity I did with them after the day of going over rules and syllabus. So this is still their summer, kind of still mushy-ish brains, coming back from a gap in their learning. And we only spent 6 days of treatment. So this was after 6 days of classroom instruction and then a comparison. Yes?
I'm just making sure I understand. And you're testing whether they understand what they've been taught last year.
No. Well, yes and no. I mean, it doesn't really matter what retained from last year to this year. What I was measuring is if they are given algebraic equations, and then they are given these instruction, we call it treatment, but the instruction using Trivium tools. And then 6 days later, they can go and take a similar test with the same number of algebraic equations and have a massive difference in terms of statistics. And I have both the chart for you, but I think sometimes, pictures say 1,000 words. So I think if you take just a look at the normal distribution of the pre-test versus the post-test, you can see that as a class, their scores went significantly higher in terms of understanding of how to solve them. And the data got a lot tighter for the post-test, which means and that's what the standard deviation measures. So it wasn't really about what they learned last year. It's really about, can we use these kind of heavily used tools in housed in the Trivium that are we've associated almost with them being language-based, can we use them in the quadrivium to help students with their understanding as well? And I think that from the study, the answer to that is yes. Interesting trends that emerged from the data included a rise in the scores for all 12 participants in Group 1, and a significant increase in the average mean, with the mean score nearly doubling after treatment. The descriptive statistics, means, standard deviations, and confidence intervals of the pretest and post-test scores are displayed in the table on the bottom left on the screen. They are in your handout on table 4. For the pretest, the data were normally distributed with skewness of 0.31 and kurtosis of 0.08. The post-test data were also normally distributed with skewness of negative 0.53 and kurtosis of negative 1.01. Although the data were skewed left for the post-test, providing visual support of the hypothesis. The figure on the bottom right shows the normal distribution graphs for the paired one-tailed dependent samples t-test conducted, and the pre-test, post-test scores is in your handout at page 28, I believe. You can see figure 1. So those were the quantitative results, and while I want to do more questions at the end, I thought this might be a good place to pause and get any questions you might have right now just on the quantitative portion of the study before I move on to qualitative. I mean, I can always back up, but since it's right up here in front of us, does anyone have any other questions right now before we move on to the qualitative part? Yes, sir.
Just a question about the tests. Were all the questions just, here's the equation, or did they have to get the equation from a word problem?
No, none of them were word. That's a great question. None of them were word problem solving, but I think that is definitely an area of future research or ways that we can really take, because you're absolutely right. Word problems, now we have the introduction of language into the problem without giving them necessarily tools on how to do that. And I actually do quite a bit of that in my classroom as well, where we learn what words or phrases in English translate into in math, and how to we work on sentence translation. We translate it from English translation to math translation all the time. So yeah, that's a great question. But no, the questions themselves, and like I said, I did bring one copy of the entire study, and I do include both pre-test and post-test in an appendix. So if you wanted to see the actual algebraic equations, you could. Good, yes?
Were they scored numerically, like so it's either entirely correct or solving equations either right or wrong?
Right, no, and that I cover in detail I explain how I do the grading process. In fact, if we have time at the end, I'll try to flip through quickly and find that. But no, so each question, I scored it on a score of 100 points. There are 10 questions, so each question was worth 10 points. And in each one, because I told them to please show your work, show your thinking, right? And so I was looking for the correct answer, but I was also looking for their algebraic processing, right? And how they would write 3 steps and moving things over and understanding what to do if the variable's in the denominator, understanding what to do if the variable is negative, all of these things. And so each one kind of had it was broken into 5 2-point things I was looking at for each problem. And I did the same type of scoring on the post-test to the pre-test. So yeah, great question, thank you. All right, any other questions? Okay, so now for the qualitative results. I used an integrated approach to develop the code structure. I utilized a software program known as Atlas TI9 to support the analysis. Word clouds were developed to ascertain frequent words used in the narrative, and you can see figure 2 for that, which is found a little bit later in the handout on page 33. And as I go through this, I encourage you to keep your eyes on page 33 because I'm going to kind of describe some of the things that happened. A text search, a regular expression search, and a sentiment analysis were then applied to frequently used words and phrases to assist in the discovery of emerging themes and in the development of coding. A few trends emerged during the qualitative interview process. There was, first, a connecting of experiences that emerged during the 2 interviews of the participants in group 1. So if you remember, they took a test, and the next day we talked. I interviewed them. Then they took the post-test at the end of the treatment, and then the next class period we talked again. As they compared their I didn't really ask them too much to do this, but they compared their pre-test and post-test experiences throughout the entire interview.
Did they know their score before they interviewed with you?
No, and they never got to see their score, and they never got to see either test. And I told them from the get-go that it was not for a grade at all, and that I just wanted them to do their best in both cases, and that they would never get to see them. And they knew that going into that. I also got permission from all the parents the summer prior for their students' participation in that. And so it was interesting because I was trying to get through the syllabus on day 1, and they were asking, what are we signed up for? What did my mom sign me up for? So I'm like, we'll get into that tomorrow. Okay, so as they compared their pre-test experiences to their post-test experiences, in nearly all comments, they described an increase in personal confidence and a decrease in confusion. In addition, each interview conducted took successively, longer to complete for me as the interviewer. Though the interviews were not precisely timed, something I wish I could go back and do it again, but you can't. The general length of interviews could be seen from the length of the transcribed text from which each interview and from the frequency that comments were made. The word cloud produced by the group 2 interview was considerably larger. That one actually went 45 minutes. I interviewed them over a lunch period, and they have kind of a lunch, and then they have like a 15-minute, we call it recess, but a lot of times it's just time to hang out for the middle schoolers and talk. And they gave it all up. They gave me I told them this would probably be about 20 minutes or so. They brought their lunch to my room, and then when the bell rang for lunch to be over and for them to have their free time, they kept talking to me, and they stayed there the whole 45 minutes. You can see that from their word cloud as well. They had also students in group 2, if you compare the words used in the group 1 interviews with the words used in the group 2 interview, the students in group 2 had substantially more to say and more words to use as they described their interactions with algebraic equations. The types of words that were used frequently by students also revealed an interesting trend. When comparing the words used in the pre-test and post-test interviews for group 1, several descriptive words paired as antonyms with one another. For example, hard in the pre-test word cloud paired with easier in the post-test word cloud when analyzing the words in context of the transcribed texts. Even identical words in both group 1 word clouds were used in opposite ways when the text was analyzed. For example, in the pre-test word cloud, the word confusing was used to describe the problems. In the post-test word cloud, confusing was always followed by a qualifying word or phrase, which the word cloud's not going to pick up, but it would be a word such as less confusing or not as confusing. And that was true for the entire transcribed text. Another word that was used frequently in both interviews with group 1 is yeah. The text analysis revealed that this word established agreement in sentiment and feeling among the participants in group 1 for both interviews. A final interesting trend from the text analysis was the considerable increase in mathematical vocabulary that the students in group 2 used when answering the interview questions. While group 1 used a few mathematical words such as decimals, solving, numbers, logic, and problems during both interviews, group 2 included significantly more mathematical terms relating to algebraic equations, including equations, isolate, reciprocal, algebraic, and operational words such as multiply and divide. The most frequent phrase used by group 2 during the interview was 3 questions, which is an example of one of the Trivium tools used in the treatment for group 1. The word analyses of the 3 interviews seem to indicate a correlation between the use of Trivium tools and students' attitude, confidence, and probably the most significant one in my mind, long-term understanding for this particular group of middle school students, providing answers to both the second and third research questions. Does anyone have any questions on the qualitative results before we move forward? And certainly you can ask questions at the end too. Yes?
Do you have any advice if last year was particularly frustrating for some students next year, just getting them onto a clean slate and feeling more positive going into that?
So one of the things that I really think, even though I think if you went and interviewed my students and you asked them what they thought of their flashcards and their flashcard quizzes, I don't think you'd find very many at all that would rave about them. I think almost all of them would kind of like, oh yes, we have so many flashcards. We have so much we have to study. We have to study them every night for 5 to 10 minutes. That's part of our homework. And then we have flashcard quizzes. And by the way, in course 2, I don't do the power up, is it the power up section of tests? I don't do that with them because I don't have time. So I've replaced that with flashcard quizzes instead, right? Because I think when they get to, I don't know if it's course 1, course 2, course 3, but definitely when they get to course 2 and course 3, while I hope they have their multiplication tables memorized and I hope they know how to convert their fractions, the bottom line is when they get to high school, they will have calculators. They will. And I mean, they really do need to know when to use a calculator and when not, and it will benefit them if they know their mathematical tables and all of those conversions and all of the decimal fraction, percent. They need to know all those. I'm not putting that down. But at that level, I believe in those middle school years, there is far more that I need them to have in their arsenal than just that, and so that's what I do with them. So I would honestly say, and I would start small, but I would have them start doing flashcards. And I would have them start studying it as if they were studying Latin flashcards and Latin vocabulary, because that will build their confidence. Okay, sure. No, I don't mind.
do you have any resources available that are created already for the Saxon curriculum that have them broken down already, like word lists or resources for recitation and repetition, like a teacher's guide?
Right, I don't. So in several, I think in several sessions, it's been said in a couple different ways, but the teacher is the guide, the teacher is the curriculum, right? And that's not saying we don't use any books, right? But this is what I am encouraging all of us to do. And it's really what those in the Trivium arts have already been encouraged to do in classical education, right? You make up the jingles, right? If there aren't jingles already there, you make something up. And the nice thing about mathematics is that if you use Saxon, the words are all bolded. The vocabulary that they need to know are bolded, right? And so have them do those. Put the bolded word on the front of the card. Write out what you want them to know on the back of the card. Now, and you may want to shorten it, right? You may want to make it short and sweet and to the point, because we're not trying to write it for a curriculum. We're trying to write it for their understanding of it, right? And then play games in class with them, right? Do a round the world flashcard quiz on Friday, right? Where they're just one stands up and you say one side and they have to tell you the back side. And sometimes you need to know them both ways, right? Sometimes there are important terms, so we have to know mathematically both ways. So I would do that, play games with them, teach them how to study them, and then empower your parents. Encourage your parents. One of the things I ask them to do is to study with their children for these 5 to 10 minutes. And about after first quarter, I bumped it up for my whole class to 10 minutes because they weren't doing it quite enough, right? And why do I do that? Well, I could study with them. But a lot of times, by the time you get to middle school and high school math, what do most parents tell you about math and their child? They can't help them anymore. I can't help them anymore. This is how they can help them. And they can do this, right? They can do this. This isn't even in Latin. So they can totally, if they can read their child's handwriting, that might be the hardest part, but they can do this. Now, I would encourage, even if there is some company out there that has made these flashcards, if Saxon, later in the summer puts it out, don't buy them. Have your kids make them. Your kids need to make them. That process of making it themselves is a process of studying. Okay. This is totally a teacher tip from a different class that I do, but I teach 8th grade U.S. history. And on almost all my history tests, I let them have one 3x5 help card that they get to make with their handwriting one side. And I tell them they can write as small as they want as long as they're not using a magnifying device to see it. Glasses must stay on their face. And do you know what a lot of my kids do?
Sharpen their pencils.
They do. And do you know how many cards they make before the test? Several. They make it, and then they set it aside, and they write smaller and more organized. And they organize it by, okay, I'll put my dates over here, and I'll put my events over here, and I'll put my major terms over here, and I'll put my people here. Do you know what they're doing as they keep making their flash? Do you know how often when I give them the test, I see them doing this? They don't. They don't use it. They don't need to use it. They have studied, and they have created it. Now, the kids who don't do that typically don't do as well on the tests. And the kids who do make it probably would have done okay and fine anyway. That's not the point. They're actually learning, because 8th grade U.S. history is not the hardest class they're ever going to have in their lifetime, right? So they're learning a method for studying, right, that they are allowed to do. And then when I get later in the course, my constitution test for them, I don't let them have a help card. And I also don't let them have a help card at the end of the year for their geography test. But I tell them, you don't get to use one, but that doesn't mean you can't make one. And then I say, why would I say that? And they all realize by then that that is a way to study their material. So anyway, that was a little side note with the flashcard, but I would have them make their own for that reason. Thank you very much for your question. Anything else before we move on to the discussion part? See how we're doing? Okay, good. All right. So there was significant, and this is where I want to pause for a minute. There was significant statistical difference between the pre-test and post-test scores. My kind of research guiding professor. I had several professors who were involved and were kind of overseeing this project, but the one who was guiding the actual writing of the research project said he never sees numbers like this, ever. What's his job? His job is to work with teachers who are putting together classroom projects to test their children, right? And again, at no point did I think of my children as I'm experimenting on them. I'm using the things I'm already doing, but I'm applying statistics, right, to that, right, to quantify it in a meaningful way. But he says he never sees they never see statistical significance. And so one of the weeks, and I really didn't need it too much, was how to write your report even though you didn't get any statistical significance. Because the vast majority of these studies, there is no statistical significance. So then you have to say, but here are the good things that came out of the study anyway, right? So this is huge for classical education and for these tools and for what we're doing every day in the classroom. There was also a substantial increase in individual scores. I mean, just as a math teacher, wouldn't you want after 6 days of math your kids to understand algebra? I mean, wouldn't that just be great? And here's a way that we can do it using what we already have within classical education. Trivium tools used during treatment seem to show far more potency and effectiveness on student algebraic understanding in a little over a week's time. And that is significant in and of itself. Trivium tools also appeared to play a considerable role in producing feelings of confidence in solving algebraic equations. Students seem to react more positively toward the process of solving algebraic equations after treatment. And because a lot of my class, and I do this for a variety of topics that we cover in course 2, because I use repetition and recitation, and I come up with jingles, and I come up with these things that I want them to say over and over and over again. And I think in my other session, I asked one of my former students, how many times in that 7th grade year did we do 3 questions out loud as a class? I don't think 500 is an exaggeration. So we had these kids saying something 500 times over the year. It's helpful for them to know that this really works and that their confidence is built, because if they're going to be like, oh, I just still don't understand it, well, then they're not going to really, I mean, it's middle school to begin with, right? So getting them to be excited about jingles in and of itself is difficult. But if they can see the purpose and they can see how it finally is making what is written on the paper in numbers and variables make sense to them, then they will continue to do it. And it's a good practice no matter what you're trying to learn that's new. Finally, the study appears to show that Trivium tools provide students with a platform that is meaningful and long-lasting. Of course, we kind of know, right? If you say something 500 times, it's going to be stuck up there. But really, they do internalize it. Most of them, when I check back with the students in high school, when I get them in geometry or in Algebra 2, and I say, do you guys still say it out loud? No. We don't say it out loud. It just kind of clicks. It just kind of comes, it kind of becomes a part of you. And likewise, if you want to liken it to foreign language again, eventually, when you're translating Latin, don't you just kind of read it, right? You don't have to every word, okay, let's parse this out, right? You just kind of, oh, I see what it's saying, and it doesn't come all at once, but it's the same thing with algebra. Eventually, you just read that in that language. So in conclusion, Trivium tools are multifaceted and efficacious. The study seems to indicate that they build student algebraic equation knowledge, understanding, confidence, and an affinity toward mathematics in general and algebraic equations in particular. Thus, we as math teachers should utilize these tools frequently in our classrooms to build understanding, growth, and mathematical fluency. Now, I have a discussion section, and then after that I have just the few references that I referenced. I have, like I said, a copy of my whole paper. There's 3 pages of references there, and certainly we could, I don't know if we can get a copy of any of this to you, but I'm sure that we can ask to see if we can do that or not. But let's go, before we do this, I wanted to take, how many of you were in my lesson planning one? Okay, just a handful of you. So let's go ahead and do this. I mentioned 3 questions. Okay, that's kind of my biggest Socratic method tool that I have developed to use with students for solving algebraic equations. And as I explained in my session yesterday, before we get to 3 questions, we have already made flashcards on some of the terminology that I mentioned, term, like terms, operations, inverse operations, and so forth. They need to have that vocabulary. That way we can go with a question answer back and forth, and eventually I have them lead it. I have them ask a question. I'll have one student come up and say the question, and then the rest of the class answers. Or I'll have a student come up and do the whole thing, question and answer from start to finish. So what we say is, we start by saying, is my variable on 2 sides or 1 side? And the answer? Good. And this works better if you just want to, like, as a group, say the answer, okay? So let's try this again. Is my variable, this is what I do with them too when it's first thing in the morning, they're like, I'm like, oh, I couldn't hear that. Is my variable on 2 sides or 1 side? 2 sides. Excellent. Okay, and which term should I move first? 2x. Very good. Excellent. And they're doing this, right? They probably have written this down on their paper. And they've done this. I always tell them wheels are optional. Right? So I just do that. I'm like, add your wheels if you want to. You know, some of the artistic ones that are really fast drawers, they're like designing their little train cars, everything, right? But terms are like train cars. Oh my goodness, you can see clearly, you know, and I'll pause sometimes. How many terms are on the left side of the equation? 2. How many terms are on the right side of the equation? 2. Yeah, when you draw those train cars, they just pop right out at you, right? Okay, so we're going to move the 2x first. How do I move it to the other side? Subtract. Right, we're going to subtract. So my kids would just say subtraction. Okay, I always teach them to do it vertically. Okay, I always go vertically. Horizontally is not a good method. And while it can work for something like this, you're still likely going to run on to the next line. But I guarantee you that when you get into Algebra 2 concepts and you're working, or trigonometry, and you need to show, it does not work to go horizontally. So always go vertically. Always show them how we are getting rid of something from one side because we're moving it to the other side. So I'm very visual with them. All right, then we rewrite what's left underneath. Okay, so we kind of draw that line, just like when we did 4 minus 2 and we're in first grade, right? We learned how to draw the line and put our answer down, so we're just going to put it underneath, right? All right, now, what is the new equation?
3 equals 2x minus 7.
What are the 3 questions to ask? And then someone will repeat my 3 questions. So we aren't even doing it yet. The 3 questions are, what is attached to my variable? How is it attached? How do I move it to the other side? So somebody will say that for me. Then I will go, what is attached to my variable?
2.
And? 7. Good. And I teach them to say 2 and 7 because I want them to see that while it's true this is minus 7, it's really adding a negative number, right? And we cover that with them, right? And they understand. I think we cover that definitely in course 1, right? Maybe even the year before. Okay. So they will just say 2 and 7 because I want them to see this as a connection between the terms, okay? How is it attached? Oh, wait. So then I say, we said 2 and 7. We can't do it to both numbers at the same time. So then I say, which one first? So which one are we going to move first? 7. Good. And all of you guys who teach math probably at like 2nd or 3rd grade teach PEMDAS, right? Okay. I also teach SADMEP, which sounds fun, right? SADMEP. PEMDAS is the way we do what? PEMDAS is the way we put things together. SADMEP is the way we move things away from our variable. So when students are trying to decide which one first, I introduce them to our friend SADMEP. SADMEP tells us that we're going to move anything attached by subtraction or addition first. And when they don't say minus 7, but they see this as an attachment between the 2 terms, they can say, well, and I can even say, how's the 2 attached to x? Multiplication. How's the 7 attached to the x? Subtraction. Which one first? Subtraction. Right, so we're going to say a number. Which one do we move first? Which one first? 7. 7. Good. So then we will say, what is attached to my variable? We're just going to say the number we just said gets to go first. So what is attached to my variable? 7. How is it attached? How do I move it to the other side? And they're doing this on their paper while you're doing this on the board. And then you pause and make sure they're still going. Everybody write it this way, still going vertically. Okay, we need to ask it again because we have another number there. So this is an example of a 2-step equation. So if you have a 2-step equation, you need to use 3 questions how many times? If you have a 3-step equation, how many times do we need to use it? What if we had a 20-step equation and they all go, I'm like, we don't have any 20-step equations. Don't worry. But how many times do we have to use 3 questions if we had a 20-step equation? Good, excellent. So what is attached to my variable? How is it attached? How do I move it to the other side? Always box your answer. 5 equals x. Then I say to them, I don't think I got to this yesterday. I was so excited about talking about this session today that I forgot to do this. Okay. Is 5 equals x the same as x equals 5? Let's try again. Is 5 equals x the same as x equals 5? You got a 50-50 shot. Let's say it is a confident answer. Is 5 equals x the same as x equals 5? Yes. Good. What property states that to be true? See, now here's where they are seeing properties in action. That would be the property of symmetry. Okay, which I show them. Symmetry, you think spin. You can spin it around the equal sign and it means the same thing. So all of these terms they're making on flashcards, and we're talking about connections and tips to thinking about them, right? Commutative property, I always make them think of a commute, right? Because they're commuting to work. As long as you have a driver's license, doesn't matter who's in the driver's seat and who's in the passenger seat, you're commuting together. So I give them like visuals and verbals for almost every term we have. And I help them to understand what those terms do. And then we use 3 questions to tie it all together. So that's 3 questions. All right, so discussion. In any order, we have like 6 minutes left. It says, what math topics do you teach? My big question is, how can we incorporate these 4 tools into our math lessons? Or we can talk about what are the benefits for kind of intentionally integrating our 7 liberal arts back into our classrooms. So, take your pick, or you may have a question of your own. Let's talk. Yes?
Share one. I like to use the Socratic method to define a circle. All right, class, what's a circle?
Yes.
It's a round thing. So then I'll draw some oblong round shape, and we can go for 5-10 minutes until we finally center on, it's the set of all points equidistant from the center.
Yes.
And then from that moment on, they always say, that's what a circle is.
Yes, absolutely. I love that. One of the similar things I always do early on when we get into whatever lesson first talks about geometry, because in Saxon, there's a lot of repetition from year to year. And so I said, okay, everybody take out your paper and a pencil. I want you to go ahead and on your paper, draw me a point. And if you can do so correctly, you get an A for the quarter. And then I say, okay, hold it up when you think you got it. You only get 1 shot. Nope, because they all hold up something and I can see every single one of them. And then we get to talk about it. It's another Socratic method. Why? Why do none of you get it? Was I lying? Was I just being unfair? Well, the answer is, what is the definition of a point? Yes, that's right, exactly. So, and then of course they like to get philosophical, and then they're like, well, then is anything true in math, right? We can't have anything. How can we even do our homework, So we say, well, this represents points, right? It stands for point. And that whole represents, stands, equals, symbolizes is exactly what we're doing with variables, even before they get to variables, right? It represents a number. Okay, good, thank you. Other thoughts, comments, ideas? Yes?
I don't mean to at all to play devil's advocate here, but I honestly want an answer to the question. We are defining terms. We are applying defining terms, grammar. We know that all of these terms work together in predictable ways, logic. We can direct all of that information toward a goal, rhetoric. What about the other words that are not math words, where the students have deficiencies and can't use the language to throw the math terms around?
Could you give me an example? Because in my experience with the kids, it could just be because I have a bachelor's in English and then a master's in math. And so I've not found many situations where I can't come up with some analogy or some verbal connection.
Right, I'm thinking about the gaps between a student's listening vocabulary, their reading vocabulary, and their speaking vocabulary, because that's going to get increasingly smaller. And sometimes I could see as a plausible problem the fact that when a student is called upon to explain certain things, they might not be able to they can parrot back to you what the words actually mean, but there's no substance to those words yet.
Right. No, and I hear what you're saying. I guess my recommendation is to keep having them parrot. Because what we know is that their brain will eventually make those connections. They will have that aha moment, even though we don't know maybe when that's going to start taking place. So until then, you keep having them parrot it. It's why I think students should memorize multiplication tables before they understand that multiplying is fast adding.
Yeah, that's the catechism, right? We have kids memorize the catechism and hymns. They don't know what all these words mean yet,
Right.
but we're waiting
Yes.
for a time when they do.
Absolutely. And we would do the same thing in math that we would do in any of the language or in theology. Good, but great question. Yeah. Yes.
I had one this past year. I was helping one of the kids with a problem. Sam makes a phone call from Chicago to Dallas. It costs 35 cents for the first 3 minutes and 10 cents a minute thereafter. How much is a 10-minute phone call? Huh? What? You just make the call.
Yeah, I know. Yes. What, you have to put coins in? Where do you put that in your cell phone? Where does that go? Yeah, it is true. I mean, we do have some things that that change like that over time. I have a couple final thoughts. I'm not seeing any other hands. One of the things I realized, again, probably even more significantly than when I was studying my undergraduate, is that Dr. Korchak's right. Dewey is kind of like not talked about anymore, really, in the educational circles, especially of higher ed. At least that was not my experience. I never heard Dewey mentioned. But you know, it's been replaced, and the current shining star in the current educational pedagogy is constructivism. It's Piaget and it's Vygotsky. Those are the two that are really being pushed. Learning cycles. I was forced to write learning cycles, you know, and as much as I could, I tried to make them as classical as I could. Sometimes I just turned it in for the assignment to show them I could write it. I'm never going to use it, right? And the most demonized component in constructivism, any guesses as to what they demonize more than anything else? They call it not real learning. They call it a hindrance to learning. They say it actually hurts students. Memorization, that's right. And they usually use that adjective rote in front of it, but sometimes they'll just use it, memorization. Memorization is not real learning. Memorization is awful. And what is, for classical educators, especially at like the preschool, the grammar level, what do we do more than probably any of the others? Memorization, right? And we know how important it is. So I think more emphasis on our part to show the benefits of memorization, kind of that positive aspect, benefits of memorization in the classroom, not letting those of us who have friends that are teaching in Lutheran schools that don't really know about, you know, what the classical liberal arts can offer their children. Don't let them kind of parrot those, oh, well, memorization isn't real learning, you know, those sorts of things, and helping them to see how beneficial it is. More integration of all of these great tools that the Trivium has done a great job of utilizing. Let's utilize them more in the Quadrivium arts as well. I think those are the things that we as mathematics teachers and those in the Quadrivium can do. So thank you very much. I will be up here if you have any other questions or if you want to see the study in full, and I appreciate your time.